All right, guys and gals, we're going to keep working with our transformations today, but instead of doing the translation, where we simply took our original image there and moved it, say, to the right or up or things like that, what we're going to do today is called a reflection, where we take our original image and we flip it over. Now, notice in this case, what we flipped over is the y-axis. Notice it runs down the middle between our two images here, our pre-image and our final image. This is known as a mirror line. So we need one of those in order to figure out, well, what is the mirror that we're, say, A is looking into, and then seeing its reflection on the other side. So the y-axis could be our mirror line. We could also use, for example, let's do it this way maybe. We could also have the x-axis be our mirror line. So if it looked into the mirror this time, it would see itself upside down. And reflections are congruence transformations, just like translations. Notice we're the exact same size, the exact same shape. Nothing's been altered about the figure except its location. And in this case, we are the mirror image. Right? So that's what we'll work on today. Not a big to-do. So let's take a look at some of these and let's see if we can figure out what's going on and then do some ourselves. Right? So let's look at this first problem here on our notes. The question that we're being asked, or the task we're being given, is that we need to describe each transformation in words and then again in coordinate notation. So let's do it in words first, and then we can go back and look at what's the coordinate notation for this. Remember, coordinate notation always starts with x's and y's to represent the original coordinates, say of q or of r or of s, and we're going to use variables because that could represent any of those points. We have an arrow that comes next. That represents our transformation, that we're being mapped onto something else. And then we'll put our final coordinates, whatever they may be. And we'll talk about that in a minute. But let's do words first. So notice I've got the black version here, QTSR, so this quadrilateral. And I notice that it appears here in quadrant 1, and then its new image appears down here in quadrant 4. Well, it looks like we flipped it up, over, and down, so it looks like it went across the x-axis. So I could say that this is a reflection. Over or across, either word. I'm going to say over because I don't have a lot of space here. So reflection over the x-axis. Right? And that's how I could describe that transformation in words. Notice we just went up, over, and then down. Cool. All right, let's talk about what it would be in coordinate notation. So again, we're going to start with our x's and y's. Remember, that represents our original pre-image coordinates, whatever they are. An arrow represents the transformation. Something has changed. And let's pick one point and just see what happened to it. All right. So notice R here. R is at the point 5, 5. So I'm going to write that down here. 5, 5. All right. R prime, all the way down here, is at the coordinate 5, negative 5. Well, that's different. Notice the x stayed the same. It didn't alter. So here, my original x did not change. So I'm just going to rewrite x because it didn't alter. Nothing was changed about it. But I want you to notice something else. The y-coordinate went from positive to negative. In other words, write this word down. We found its opposite. All right, because imagine with me, pretend that this is the black and this is the blue. This coordinate is at 5, negative 5. If it reflected from here up to here, it went from from negative to positive. Again, we found its opposite. So here's what we're going to say. We're going to say for this transformation, x stays the same and y becomes opposite. Not necessarily negative. It's just going to be made the opposite of whatever it was before. So here it was positive, so its opposite, of course, is negative. If this was the original point, negative, then its opposite would be positive. So when we see this sign, we're not going to read it as negative. We're going to read it as opposite. All right, so keep that in mind. That's really going to make your life a lot easier. Trust me. All right, well, let's look at the next one, number 2 there. So here's our black image. That's the pre-image. It looks like it's in quadrants 3 and 4. And its final image looks like it ended up in quadrants 2 and 1. All right. Again, I'm imagining picking this up, putting it in its new position. It looks like it too went up and over that x-axis. So we can say in words that this is a reflection over, if my pen will write, over the x-axis. axis. All right, cool. And that means the coordinate notation for this image is exactly the same as what we had here. In other words, I started with my original x's and y's. So for example, like D here, D was at 2, -4. So I'm going to write that down, 2, -4. The arrow, remember, represents that we've got a transformation. Something's happening. We're moving it from here to somewhere else. Notice that at D prime, the x coordinate doesn't change. This is still at 2. So x stays the same. But notice the y. Here, we've got a -4. When I move it, when I transform it and reflect it up and over, now all of a sudden that 4 is positive. In other words, from -4 to +4 is the opposite. So again, opposite y, not negative y, opposite y. All right, so very good. Let's try it again. Uh-oh, this time we've got something different. This time it looks like, here's my original, it looks like I've brought it up and over from left to right. So that means it looks like it's gone up and over the y-axis this time. So here's that y-axis. Notice both sides kind of mirror around it. So I could say that this is a reflection over the y-axis. Now, let's talk about its coordinate notation. All right. Notice, for example, here at point G, that the y doesn't change. Here, it's all the way down at -4, and G prime is all the way down at -4. So the y didn't change. From here to here, it's at the same level. But notice the x. Here, our x coordinate would be at -1. Its reflection is over here at +1, so it's an opposite. So notice for a x-axis reflection, x stays the same, y becomes opposite. For a y-axis reflection, x becomes opposite and y stays the same. So whatever axis you're going over, that's the coordinate that's going to stay the same. All right? So if we look at this one, now I'm noticing here that our two images are kind of intertwined. And that happens from time to time. And sometimes you can get this real neat kind of pretty effect. You know, here, for example, kind of looks like a butterfly. Here, for example, I'm not sure what that is, but they're kind of mixed together. But I noticed, for example, that W to W prime is over that y-axis from here up and over to there. So it's still a reflection over the y-axis. And the coordinate notation is simple. It's exactly the same as what we saw here. So anytime I go over the y-axis, so again, my original x's and y's, whatever they are, so in this case, W is at 4, -2. So let's write that down. 4, -2. Notice that 4 is positive here, but if I go over, 4 is negative here. I've gone from the origin left 4 spots, so x is opposite. But notice the y is the same. I still went down 2 here. Well, notice I still went down 2 there. So the y is unchanged. I didn't alter the y's there. So this coordinate, of course, is at -4, -2. So notice x's are opposites, y's are the same. All right. Well, let's actually do one of these. Let's actually draw them out. And actually, we'll do more than one. Let's take a look at number 5. We're going to reflect this across the y-axis. And notice we're asked to graph the image using the transformation and write out the coordinate notation. So I'm going to write the coordinate notation first just to get that out of the way. It's pretty easy to do. Reflection across the y-axis. So my coordinate notation for this, x's and y's are starting out. There's our arrow to represent. We're going to change them. And remember, if we're going over the y-axis, then the y would stay the same and x becomes opposite. So that's the coordinate notation for reflections across the y-axis. You will want to memorize these coordinate notations, folks, by the way. All right, well, let's talk about one way that we can do these transformations. One way to do it is to count. Let me show you what I mean. Let's look at Q, for example. Q is 1 box away, and I'm going to make this a little bolder so we can see it. There's the y-axis. It's our mirror line. It is 1 box away. See? 1 box. If you're looking into a mirror, if you've ever gotten up real close to the mirror, it kind of looks like your reflection gets close as well. So if Q is 1 box away, then on the other side, that's where Q prime will be. It'll make it look like it's really close. Now, if I look at T, for example, T is a little further back. And if you've ever stood in front of a mirror and walked back from it, it looks like your reflection walks away as well. It's the same distance out. So T is 1, 2, 3 boxes out. That means T prime is, count them with me, 1, 2, 3 boxes out on the other side. All right, so this is one way we can find our new coordinates, is by simply counting them out. So let's go up here. R is also 1 box away, so we'll count 1 box out. There's R prime. Make sure you're using your prime notation there, folks. And then S, of course, looks like 1, 2 boxes out, so we'll count 1, 2 boxes out, and there is S prime. All right, let's play connect the dots real quick. Notice our two figures are the same size, the same shape. In other words, they are congruent. All right. Translations are congruent transformations, and so are reflections. We should get the exact same size and shape. The only difference here is that they're mirror images of each other, but they are still congruent. All right. Let's try another one. This time we're going to go across the x-axis, so I'm going to make that a little bit darker. If that helps you as well to make it darker just so that you can see what you're doing, that's fine. You certainly don't have to, but I'm going to make that line just a little bit darker so I can see it. Let's write out the coordinate notation. So again, we start with our x's and our y's, whatever they are, we don't really care. When we go across the x-axis, however, the x coordinates stay the same. The y's become opposites. All right. So let's do our counting method. Now, I've noticed something here. H sits right on the mirror line. And remember, reflections are going to be the same distance away. For example, R was 1 box away, so R prime is 1 box away. Well, H is 0 boxes away. So that means H prime is also 0 boxes away. In other words, H and H prime in this case are going to be the exact same coordinate. And it happens. All right, well, let's look at I. I is kind of far out here. I is 1, 2, 3 boxes away, so I'll just count 1, 2, 3 boxes away. And there is I prime. But notice something. J isn't above the line. J is actually below the line. So when I count 1, 2 to the line, I better count 1, 2 above the line. Again, they're opposites. So J prime. Let's play connect the dots. Notice this time our images are kind of intertwined, and we get this sort of butterfly effect. That happens. We're not too concerned about it. But notice I is 3 boxes away, just as I prime is. J is 2 boxes away, just like J prime is. And of course, H and H prime sit in the same spot because they're 0 boxes away. All right. And again, notice they are still congruent. Both triangles are the same size and the same shape. All right. Let's try a couple more, just to make sure we got this. All right. This time we're going over the x-axis. So let's bold that in real quick, just so we can see it. Makes it a little easier when we're counting too. These lines start to all look alike. Our coordinate notation, because we have to write that out, the directions asked us to, is x, y, maps on, that's what that arrow means, maps on to, or is changed to. In this case, if we're going over the x-axis, x's remain the same and y's become opposite. All right, that's our coordinate notation. So let's look. D is 1, 2, 3, 4, 5. Goodness gracious, 5 away. So on the same line, I'm going to count up 1, 2, 3, 4, 5. There's D prime. Always label your points, folks. Always. C is 1, 2, 3, 4. All right, so let's count 1, 2, 3, 4 on the opposite side there. So there's C prime. B looks like it's also 4 units out. So 1, 2, 3, 4. Yep, we were correct. So 1, 2, 3, 4. There's B prime. And then at last, A is 5 out. So we'll count 1, 2, 3, 4, 5. And there is A prime. We play connect the dots. And notice we get a mirror image. We don't want a translation. We want a reflection. So be very careful. In other words, if I fold this paper, my new image should fold directly on top of that pre-image and match up exactly. All right, let's try one more this way. Then I'll show you the fast way to do this. Because this counting stuff, I mean, if you want to count, you're all for it, but there is a quicker way. I'll show it to you. Let's do this last one. We're going over the y-axis this time. So let's get our coordinate notation first. So x's and y's are where we start. It'll map on or change to. If we're going over the y-axis, then the y stays the same. X, remember, becomes opposite. We do not read this as negative x. We read it as opposite. All right, so let's get that y-axis kind of bold. So I'm going to do that. And again, you don't have to do this step, but I like it just so that way I can see it. Being visually challenged, it helps. So R, notice, is right on the line there. So that means R prime is going to be in the exact same spot. So these 2 points share one location, and that's fine. Let's take a look. S is 1 box away, so I'm going to go 1 box here to the left as opposed to the right. And there's S prime. Notice T is 1, 2, 3 boxes on the right, so we're going to go 1, 2, 3 boxes on the left. So there's T prime. And then Q is 1 box on the right, so we're going to go 1 box to the left. Q prime. Now we can play connect the dots. And again, if you need to use a ruler or something, by all means, do that. Makes the lines look a little bit nicer. Ta-da! Notice congruence. They're the exact same size, exact same shape. The only difference is we have a mirror image. All right. Let me show you a quicker way. All right. Let me show you a little bit faster way of getting this stuff done. Because counting works, it just takes time. Let's talk about a quick way. So we're asked to find the coordinates of the vertices for each figure. In other words, we're not asked to draw. We're just asked to find where the coordinates are, not to actually draw them in. So this is faster. Take a look. We're going to go across the x-axis. So I'm going to write out the coordinate notation real quick. So again, we start with our x's and y's. And then if we go across the x-axis, x stays the same. All of our y's become opposite. All right, so take a look. Let's get all of our original points here. So we've got B, C, and D. Let's get them all in. B is at 0, -3. So let's write that down, 0, -3. C is at 0, 1. D is at 3, 1. All right, let's find the new coordinates, and I'll show you that it works. So we've got B, C, and D prime. Don't forget your prime coordinates there. Oh, let's see. There we go. X's stay the same. So 0, 0, 3 doesn't change. 0, 0, 3 doesn't change. Y's all become opposite. So take a look. That 3 is negative. Its opposite is a positive. Okay? 1 is a positive. Its opposite is a negative. 1 is positive. Its opposite is a negative. And ta-da, I've got all the points, no counting required. Now let me show you. Obviously, we don't have to graph, but I'm going to graph this for you just that you can see this is going to be a reflection over the x-axis. So B prime is now here at 0, 3. C prime is here. D prime is here. And notice that butterfly effect again. But ta-da, we've got that reflection in a much, much quicker time, and you did not have to count. Much, much easier process here. All right? So let's try it again. This time we won't graph anything. We'll just do the process. So we're going across the y-axis. So x's and y's will map to, since we're going across the y-axis, y stays the same there, x becomes opposite. All right? So we've got I, J, K, and L. So let's get those original coordinates. I is at -1, -2. J is at 1, 1. K is at 3, 0. L is at 1, -3. All right, let's get all of our new coordinates drawn in. So we've got I, J, K, and L prime. All right, x's become opposites. So this -1 becomes positive. This +1 becomes negative. +3 becomes -3. +1 becomes -1. Again, this means opposite. So whatever this is, make it the opposite. Whatever this is, make it the opposite. Y's all stay the same. So -2, +1, 0, -3. We're done. All of these will be the new coordinates for where this image will end up. And again, I'm not going to graph it for you. We don't need to. We just need the coordinates. But if you're ever unsure, you could take those coordinates, graph them out, and see, do you get that nice congruent image? If you do, cool, then you're right. If you don't, then double check yourself. All right, let's try it again. Reflection across the x-axis. So again, if we're going across the x-axis, the coordinate notation for that tells me that after I get my originals, that x will stay the same, y will become opposite. All right, so we got s, t, and what is that? U. Let's get our original coordinates in. S is at 4, 2. Looks like t is at 0, 4. U is at 0, negative 1. All right. Let's get our new coordinates in there. So S, T, U prime. Again, don't forget your prime coordinates. X's all stay the same. So 4, 0, 0 doesn't change. So 4, 0, 0, those don't change. All right. All our Y's become opposites. So in this case, 2 becomes negative 2. 4 becomes negative 4. Negative 1 becomes positive 1. Cool. And we're done. So using coordinate notation is always going to be a lot faster than using this method of getting our new image by counting. Counting works and it gets you a good image, but this is a lot faster. And with this last one, I'll go ahead and graph it for you just so that you can see it. So in this case, we've got, what have we got here? R, S, T. Oh, I forgot. Got to do our coordinate notation there. We got X's and Y's to start. And since we're going over the y-axis, x becomes opposite, y stays the same. R is at negative 4, negative 1, so let's write that down. S is at 1, 1. And then t looks like it's at 1, negative 3. Did I count that right? 1, yep, negative 3. I did count that right. Excellent. Let's get it on there. So R, S, T, prime. X's all become opposites. So negative 4 is positive 4. Positive 1 is negative 1. Positive 1 is negative 1. So opposites. Y's all stay the same. So negative 1, positive 1, negative 3, they weren't changed. They stayed the exact same as they were originally. All right, let's draw it. So R would go here. I'm going to get into my work a little bit. S is here. Oh, that should have been a positive one. I misread that. That's a positive one. Notice, or no, excuse me, I did read that correctly. Nope, I did read that correctly. I graphed wrong. Negative 1, got to go this and up. So that's there. Don't want that point. And then let's see here. Well, no. No, I completely botched that. Notice I was supposed to go up or supposed to go down rather, and I went up. All right, well, let's redraw it here. We can save the day. And again, this is why, folks, you got to pay attention. So 4, negative 1, 4, it was supposed to be, yep, 4, negative 1. So right, 1, 2, 3, 4, and then down 1. So there's R prime. It helps if you can count. S is at negative 1, 1, so it would be up here. And then T is at negative 1, negative 3. That's all the way down here. Another good reason why you should do your work in pencil and not pen, but I do it in pen so you guys can see it a little better. There we go. So notice here's my original, here's the new one, and they are reflections, same size, same shape. Again, I would use a pencil, guys. That just makes it easier so you're not as likely to make a mistake like I did. Again, I use pens so it makes it easier for you to see. If you have questions, concerns, please let me know. We'll work some of these out in class today, so if there's any of these that you're like, holy crap, I don't know how to do it, we'll work on it together. Please bring your questions. Let me help you. Have a good day, guys.